Have you ever stopped to just look at your hand? I mean, really look at it. It's so much more than just a part of your body. It is an absolute masterpiece of biological engineering. We're talking about an intricate 27-bone machine that lets us do pretty much everything. So let's dive into the incredible architecture that's packed into this amazing little space. Okay, let's start with a quick riddle. What has 27 moving parts and is responsible for building, well, pretty much our entire modern world? Yep, it's the human hand. All of its 27 bones work together perfectly with muscles, ligaments, and tendons to give us a level of dexterity and creative power that is just unmatched. It's a biological marvel that, let's be honest, we usually take completely for granted. Now, these 27 bones aren't just a jumbled mess. They're actually neatly organized into three distinct groups. As you can see right here, we've got the phalanges, those are our fingers, then the carpals, which make up the wrist, and finally the metacarpals, which form our palm. So to really get how this all works, let's start our little architectural tour right at the foundation. And that tour begins with the carpal bones. Just think of these 8 little, kind of funny-shaped bones as the flexible but super sturdy foundation for the whole hand. They're the crucial connection point to the forearm. And you can see here, the way they're arranged is just brilliant. They're set up into 2 neat rows of 4. The proximal row, that's the one closer to your arm, has the scaphoid, lunate, triquetral, and pisiform. Then you have the distal row, closer to the fingers, with the trapezium, trapezoid, capitate, and hinate. This 2-row structure is the whole secret to the wrist's amazing combo of being both stable and incredibly mobile. Okay, so building up from that carpal foundation, we move into the palm's framework, and this is formed by the 5 metacarpal bones. You can picture these as the long structural beams that give your hand its shape and breadth. So what's their main job? Well, they're the vital connectors. They basically bridge the gap between those compact wrist bones and the more delicate finger bones. They create the main body of the hand and give us the space between our fingers. And the way we number them couldn't be simpler. It's really straightforward. We start from the thumb side and we just count across. Metacarpal 1 connects to the thumb, 2 to the index finger, and so on, all the way over to metacarpal 5, which connects to your pinky. Easy as that. But here's the cool part. They aren't all the same. Not at all. It's a classic case of form follows function. The first metacarpal, for the powerful thumb, is the shortest and the strongest. The second one, for your index finger, is the longest, giving you that pointing reach, and the fourth is noticeably slender. Each bone is perfectly tailored for the job it needs to do. And that brings us to the very tip of our structure, the phalanges. So if the carpals are the foundation and the metacarpals are the framework, then you can think of the phalanges as the precision instruments. They're the reason we can do all the fine, delicate manipulations that make our hands so incredibly special. These phalanges actually make up the majority of the bones in our hand. Each of your 4 fingers has 3 of them, a proximal, a middle, and a distal one. But, and this is a key difference, the thumb only has 2. This unique 2-bone structure is a huge part of what gives the thumb its amazing strength and opposable dexterity. So we've seen the final architecture, which is amazing. But how does this whole complex structure get built in the first place? Well, the story starts way before birth, through a process called ossification. That's basically where a soft cartilage blueprint slowly turns into hard bone. And this timeline is just fascinating. The whole process starts incredibly early, around the 8th week of fetal life. That's when the shafts of the metacarpals and phalanges start to harden. But the carpal bones, they actually wait until after birth to begin ossifying. And then, finally, in late adolescence, the ends of the long bones fuse to the shafts, and construction is officially complete. Of course, no architectural marvel is perfect, right? They all have their vulnerabilities. So now that we understand the design, let's take a look at some of the common structural flaws, or in other words, the injuries that happen most often to the hand. And here's a really key insight. Before we had modern imaging like X-rays, we really underestimated how often those tiny carpal bones were the real source of wrist problems. X-rays revealed that this compact little foundation can actually be surprisingly fragile if you put it under the wrong kind of stress. We can get even more specific. The single most commonly broken carpal bone is the scaphoid. The capitate is another one that gets fractured pretty often. That means 2 of our 8 foundational bones are particularly vulnerable to breaking, which is super important to know when diagnosing wrist injuries. So the next time you pick something up, or type a message, or even just wave hello, take a second to remember that intricate 27-part marvel that's making it all possible. This incredible machine is quite literally in your hands, which leaves just one question. What will you build, create, or discover with it?